Now, let's move on to the next step after gluconeogenesis: glycolysis. Glycolysis occurs in the cytosol of the cell. It is a metabolic pathway that creates ATP without the use of oxygen, but can occur in the presence of oxygen as well. Even if cells primarily use oxidative phosphorylation, glycolysis can serve as an emergency backup for energy or serve as the preparation step for oxidative phosphorylation. It is also known as the breakdown of glucose to pyruvate. This process consists of two phases. Let's start with the investment phase. The investment phase is where two ATPs are added to the 6-carbon molecule, which will then be split into two pyruvates that will each produce one NADH and two ATPs in the next phase. The next phase is called the payoff phase. The simple 6-carbon sugar molecule, glucose, breaks down into two pyruvate molecules, each of which contains 3 carbons. During this process, 2 hydrogens and 2 electrons are released, except for one H+, transferred to NAD+ molecules, becoming NADH for later use. In addition, some of the energy stored in the chemical bonds of glucose is used to convert ADP into ATP. After glycolysis, the transition reaction takes place. This is the transition between glycolysis and the citric acid cycle. It involves the conversion of pyruvate into a 2-carbon acetyl group that will attach to coenzyme A to form acetyl-CoA, producing 2 molecules of NADH and 2 molecules of carbon dioxide. In short, this is the conversion of pyruvate to acetyl-CoA. In detail, each 3-carbon molecule of pyruvic acid will be decarboxylated and dehydrogenated and converted to a 2-carbon acetyl group, which will react with a large complex coenzyme called coenzyme A to form acetyl coenzyme A, or acetyl-CoA. During this process, 2 molecules of NADH and 2 molecules of carbon dioxide will be produced.